This is a result of a single sentence that a human has written. Instead of several interactions where users have to navigate through the UI, they can just tell it to agent and it's executed. Let's get into it and see how it's done. We've opened our Claude Code terminal and we can tell it, please bridge 20 USDC from Arbitrum onto Solana. We can see that the deBridge skill has been successfully loaded and several tools are allowed. deBridge MCP server is available in this repository. We've added it in the mcp.json file. You can also add it to your global settings, but I prefer to do it this way to keep everything isolated and not bloat my context. I talk more about the deBridge MCP server in this video, and you're welcome to check it out. RPC calls are being performed and our alchemy key is being used here to get the actual balances of what we have both on Arbitrum and on Solana. To perform a cross-chain swap or any swap with ERC20 tokens, it's required to provide approvals for balance to be spent. In this case, the agent figures out correctly that the balance approval is not already made for deBridge and it creates it. It has correctly approved 20 USDC to deBridge spender. There's a deBridge flat fee. It's a small fee paid in native tokens for cross-chain transfer services. Since we have enough ETH to cover that flat fee, the cross-chain transaction will be performed. And right now we can see the results. Approval transaction, bridge transaction, deBridge order, and we can see the updated balances. Okay, so we've demonstrated how cross-chain swaps work. How does the agent know which tools to call and how to chain them together? Well, to explain that, we'll take a look at this chart. You can see the user interacting with the agent, and the agent interprets the intentions of the user based on the skills which are available to the agent. Skills are actually instructions for your agents on how to behave when doing specific things. For instance, agents can usually figure out on their own how to do things, but it takes them time, and every time you want another agent to do it or in another session, it has to spend time again. Of course, you can use memories instead, but memories aren't really transferable from my computer agent onto yours. So a good thing is that you can define behaviors for your agents in skills, and the agents will follow the skills when they're triggered by keywords. Essentially, skills are a manual for your agent how to use things, a tutorial in a sense. Currently, we have a deBridge skill, which has a description that covers both cross-chain and same-chain swaps, bridges, transfers, and it uses deBridge MCP under the hood and OWS wallet for signing. For this skill to work, there are several prerequisites, some of which are cast and OWS being installed. The agent interacts with the deBridge MCP server, which provides it ready-to-sign transaction data for both cross-chain swaps and same-chain swaps. Additionally, it allows it to fetch tokens, token addresses, by the name, by the ticker, everything that a user would need to actually complete the trades. Once users have ready-to-sign transaction data, they need to do the actual signing. And actual signing is done by the awsCLI, which is Open Wallet Standard. It's something that agents can use to interact with your wallet without actually having access to your private keys. All crypto users know that private keys are extremely sensitive. And since agents, when you talk to them, don't really know who they're speaking with, is it an instruction that came from you, the actual user, or is it an instruction which came into its context from one of the documents that have been included while doing some research? That way your private keys can be easily posted on someone else's server or just simply leaked. Additionally, there are more sophisticated sources of attack which can pollute the context and switch the addresses which you are currently using. And instead of sending the funds to you, they can be sent somewhere else, or the API key might get just curled and posted on some random server. Not the best thing to do. So that's where OWS comes in. OWS signs the transactions without actually dealing with a private key, and you get to isolate your account just for an agent. To avoid dealing with that threat model, we're using a dedicated signer which signs the transactions. For that signer to work properly, we will need some sort of an interface tool, because deBridge returns the transaction data, but still for EVM it needs to be RLP encoded, and for Solana there are other caveats like block hash rot. To get the current balances and submit the transactions using OWS, we will need RPCs. Remote procedure call URLs. That's what tools like these use to actually submit the transactions onto blockchain. And when speaking about OWS, it would be really nice if we checked which chains are supported. Here we see a list of wallets. EIP 155, Tron, and Solana are of particular interest for us because those are the chains that deBridge supports. Ethereum on its own covers a lot of chains which are EVM compatible. You can see the list of chains in our documentation. Not all of these chains are supported out of the box by OWS. That's why we provide a chains.json file, which specifies chain names, chain IDs, and the RPC URLs. For this to work correctly, you will have to provide your Alchemy API key. For the purposes of this video, it was the most convenient way of providing RPC URLs instead of using the public ones. Public RPC URLs are not the most reliable ones, at least from my experience. In the .env file, just paste your Alchemy API key after you register, and the agent will be ready to use it with the rest of the toolchain. So far from our diagram, we've covered skills, agent, deBridge MCP, signer, and the RPC calls. What remains is the interface tools, because OWS is a tool, Cast is a tool, LLM is a tool, and you need to create interfaces between them to work correctly. The interface tools for this particular sessions are Cast from Foundry, which is served to make RLP encoded transactions out of the transactions which are returned by the deBridge MCP server, because OWS requires RLP transactions to do the actual EVM transaction signing. And when it comes to Solana, we've provided utility scripts which prepare the transaction for the actual signing, since submitting Solana transactions has its own caveats, which make them particularly tricky for agents to deal with them. When you're speaking about approvals and the flows in general, it is pretty simple, but all of those steps are actually algorithmic execution, and that algorithmic execution is handled by agents in this case. When it comes to trading, around 50 to 60% of daily volume is handled by high-frequency traders. They create around 300 orders and cancellations of said orders per second. Humans or LLMs can't compete with that. But what LLMs can do is automate a lot of strategies. LLMs can automate dollar cost averaging or other trading strategies which you might come up with. Essentially, you can automate day trading with your LLM agent. That sounds pretty cool to me. So now that we've transferred 20 USDC from Arbitrum onto Solana and explained how it works roughly, let's do another thing, another trade. Let's swap 5 USDC on Solana into Sol. Right now it's fetching what Sol is by using the deBridge MCP server, and we get a quote and who the best execution route comes from. In this case, it comes from Jupiter. A very nice thing when it comes to deBridge same chain swaps is that deBridge uses several same chain swap aggregators and provides you always with where the best quote came from. After we confirm it, we'll see the rest of the tool calls. Here you can see that the Alchemy API key is being loaded and it's being used as an environment variable. Right now we can also check the balances and see where we are at. Savvy viewers might wonder, but why do we need interface tools? Aren't agents and LLMs smart enough to come up with solutions on their own as to how to connect the dots together? Well, they are. But the thing with LLMs is that they will reason how to make everything work. And when it comes to chains like Solana, which requires a very recent block hash, reasoning is not your friend. When you have to reason about skills and how to achieve something, the block hashes will rot, which means that they will expire and the LLM has to get another one. And if it doesn't get it in time and it has to reason about more, it has to get another one and another one and another one. All of that time, the LLM will be generating code which interacts with all of these tools. And it's not the most convenient way of connecting them. It is much more pleasant both for you as the user in the user experience way and the LLM to not waste tokens and jump straight into the execution. That's why we've prepared a Solana transaction CLI, which takes Solana transaction hex data delivered by the deBridge MCP and the RPC URL provided in the chains.json file. You're welcome to check out the script on your own, but the gist of it is that it simulates the transaction, adjusts the priority fee to be up to date, and fetches a recent block hash. That way, the transaction is ready to be signed by the OWS signer and transmitted using an Alchemy RPC. For instance, if you don't use Cast to encode transactions or to convert numbers into a human-readable format, LLMs will run their own code, and that code also needs to be reviewed well because it's working with your funds. Let's try something which requires a bit more nuance. That would be a cross-chain transfer from Arbitrum onto Solana, something which we've already covered, but you can notice that right now we don't have enough ETH. And we don't have enough ETH because deBridge requires a small flat fee covered in a native currency to be paid when performing cross-chain transfers. And right now we can say, please bridge all of the USDC from Arbitrum into USDC on Solana. Again, each time ERC20 tokens are being moved, an approval is required because the funds are being spent in your stead by the underlying smart contract. It's evident that an emergency fee swap is required, and some USDC is being swapped into ETH so all of the fees can be covered. The remaining USDC funds will be transferred onto Solana in the second transaction. A very cool thing when it comes to the user experience is that right now we don't really have to think about the individual transactions. We're just expressing an intent and something is happening. In this case, we're simulating the intent-based execution while the underlying transactions are being performed on-chain. On our recent ecosystem call, we've released a lot of information about our upcoming protocol upgrade. That protocol upgrade introduces a new DeFi primitive which changes the execution model from transactions first into intents first. What that means is that users can just express an intent to do something and it'll be done for them. It will simplify LLM flows by a large margin, since LLMs won't have to deal with transactions. And right now we're dealing with a lot of transactions. They'll be just dealing with signatures. Agents and human users alike will not have to babysit transactions while they're being executed. They will just have to express an intent and the underlying system will provide the steps to achieve it. Our upcoming protocol upgrade enables users to move funds from one chain onto several or from several chains onto one. When agents using the deBridge MCP server have a proper skill, a similar thing can be achieved. So let's introduce Base chain into the mix. So let's transfer some of our USDC both on Base and on Arbitrum. Please transfer 10 USDC from Solana into Arbitrum ETH and 10 into Base ETH. Here we are expressing an intent and that is what is going to happen. Here's the bridge plan and now we're going to confirm it. An interesting thing with our upcoming protocol release is that these would happen atomically. Solvers would provide liquidity on both destination chains before trade on the source chain is being executed, and it would be a single trade on the source chain instead of two. Additionally, and this is really great news, the flat fees are being removed. And now when we check the balances on all of the three chains, we can see how much we got. So to wrap it all up, we've covered how agents interact with a whole suite of systems around them to achieve on-chain transactions and perform intent-based trading. Here we have demonstrated an experimental way of how agentic trading works. This is something that pretty much anyone with access to an agent or Claude Code or whatever you're using can use in their daily life and daily trading. You're welcome to check out both the DeBridge MCP server and the DeBridge skills repositories. The links are in the description. And when you create your Alchemy account, make sure to enable all of the networks supported by DeBridge. The links are in the description. To run these examples, you will need to have prerequisites installed on your machine and to create an Alchemy account with enabled RPC endpoints. Paste your API key inside of your .env file and you're good to go. Like, share, subscribe, and follow us on X to stay tuned for updates. Thank you for watching, and until the next time.